Hello everyone. I am Ritik and welcome to Backend Radio podcast. And today's podcast we are going to talk about ins and outs of the load balancer. So, what is load balancing exactly? We are going to learn about. So let's start this podcast. So when a website becomes extremely popular, the traffic increases and load on a single server also increases, right? So on the concurrent traffic overwhelms the single server and the website becomes slower for the user, right? So in order to meet the request for these high volumes of data, we need to scale the server. We need to scale the server, which means we need to increase the scalability of the system, and this can be done by adding more servers to the network and distributing all the requests across these networks. Now that more servers are added to serve users, there is another problem that we must consider. What if all the load still falls on a single server, though we are though there are many other servers available, right? So this scenario could again cause unnecessary load, though you have scaled your infrastructure. We have more server, but still our requests are going to only single server, correct? So in that scenario, a load balancer comes into picture and it ensures that the load is distributed evenly across all the deployed server. Correct. Let's suppose if you have four servers deployed, so load balancer ensures that each server gets requests and every request is going to distribute to multiple servers. So load balancing is a technique which used to distribute network traffic across a pool of server. Now what does it mean of pool of server? Pool of server is means group of servers, group of deployed server. Load balancer optimize network performance, reliability and capacity, reducing latency and demand is equally distributed among the multiple servers, sorry, not the load balancer, among the multiple server, correct? Now how you might be thinking about how does the load balancer choose the backend server, correct? So load balancer choose the server to forward a request based on a combination of two factors. First, health check, and the second one is predefined algorithm. Now what does it mean by health checks? So load balancer should only forward traffic to healthy backend server. What does it mean? It means load balancer monitor the health of every backend server, and health checks regularly attempt to connect to backend server using the protocol and port defined by the forwarding rules to ensure that servers are listening. If a server fails a health check and therefore is unable to serve requests, correct? If a server fails a health check, it means a server is unable to serve the request. It is automatically removed from the pool. Okay. So and traffic will not be forwarded to that unhealthy server until it responds to health checks again. Okay, that's the first factor, which was the health check. Okay, now second factor is load balancing algorithm. Load balancer uses different load balancing algorithm and each load balancing algorithm provide different benefits. Okay, so the choice of the load balancing algorithm depends on our needs. So we have some of the load balancing algorithm. First, one is the most popular, which is the round robin. In this algorithm, requests are distributed across the group of servers sequentially, means one by one. Let's suppose we have five servers. One request come, it is redirected to the first server. Another request come, it will redirect to the second server. Another request come, it will redirect to the third server. So a load balancer distribute requests sequentially to the servers. Okay. Second algorithm is least connections. What does it mean? Whenever a new request is sent to the server, every time new request is sent to the server with the fewest current connection to the client. Let's suppose server 4 has fewest client, only 3 clients, and other servers has more than 3 clients. So the next request will be redirect to the server 4, which has 3 clients, 3 current connections. Okay. Now third algorithm is least time. What does it mean? In this algorithm, it sends request to the server selected by a formula that combines the fastest response time and fewest active connections. Okay. Next algorithm is hash algorithm, which means it distributes requests based on a key we define, such as the client IP address or the request URL, and we calculate the hash value, and we distribute requests based on that hash value. So these are some of the load balancing algorithms, and this is introduction about, and this is some not the this introduction, it is the it is about the load balancer. And next topic is types of load balancer. Okay, so we classified load balancer into two category. First one is the layer 7 load balancer, which means application load balancer, and second one is layer 4, which means network load balancer based on the OSI model. Okay, layer 7 means application layer of the OSI model, and layer 4 means network layer of the OSI model. Okay, so we have two types of load balancer. Now, what are the benefits of load balancing? Okay, load balancing improve the scalability. Load balancer scale the server infrastructure on demand depending on the network requirement without affecting the services. Correct. For example, if a website starts attracting a large number of visitors, it can cause a sudden spike in traffic. And if the web server isn't able to manage the sudden influx of traffic, the website might crash. So the load balancing can spread the extra traffic across multiple servers, preventing this from happening. Second benefit is it improves the efficiency. Due to the reduced burden of traffic on each server, the network traffic flows better and improves the response time. Correct? So this ultimately provides a better experience for site visitors. Third is it reduces the downtime, because companies with a global presence and multiple location in different time zones can benefit from load balancing, especially when it comes to when it comes to server maintenance. Correct. For example, a company can shut down the server that needs maintenance and route traffic to the other available load balancer without causing service interruptions or downtime. Correct. It efficiently next advantage or next benefit is it efficiently manage the failure. In the event of failure, load balancer automatically redirect traffic to functional resources or backup options. For example, if a failure is detected on a network resource such as a mail server, so load balancer can redistribute resources to other unaffected areas to prevent service disruptions, right? So these are some of the main topics or main things about the load balancer, and I hope you learned something. Something is something new, not the new, but I hope you learned something. So thank you for joining this podcast, and I hope you are doing well. Thank you, guys.